Welcome to video 29, Ordering Fractions.
Ordering fractions can be really easy, especially if all the fractions have got the same denominators. Because what we're saying here with all of these denominators is that all of these wholes here have been cut equally into 5. And it's really important, if you were to draw these out, that these wholes and these sections need to be completely the same. So we're going to order these fractions here from the smallest to the biggest. So here we've got 1/5. We've got one whole that's been cut into 5 pieces, and we're looking at just one of them. And this time it's really important that we colour from the top down or the bottom up, but we do it to all of them so that we can do a good comparison. Next one, we've got 4/5. Again, one whole exactly the same size as this one, and it's been cut up into 5 equal pieces exactly the same as this, so we can make a comparison, and we're looking at 4 pieces. Next one, exactly the same whole, exactly the same equal pieces, 5 pieces in total, and we're looking at 3 of them. And the last one, 2/5. I'm not going to explain it again, that'll be the 4th time explaining it. Okay, now you can see from the visual representation exactly which one's the smallest and exactly which one's the biggest. But if we just used our understanding, we know that 1/5 is going to be smaller because there's only one part, and 4/5 is going to be bigger because we're so close to one whole. But we'll rely on our visual representation and we'll put them in order from the smallest to the largest. So smallest is going to be 1/5, so we've only got one small piece. So here's my line, and there is 1/5. Largest is 4/5. We've got more pieces coloured in. We've only got one more piece left until we've got one whole piece. So, and the biggest is going to be 4/5. I think we're going to go for the next largest, so the one along, which would be 3/5. We've still got 2 more pieces to go. And the last one in between here would be 2/5. So very, very easy to order fractions when we have got the same denominator. It's a little trickier when they've got different denominators. So I've got here 1/6, 4/5, 3/8 and 2/9. And if you are going to use the visual representation, it's really important that all of these pieces are the same size and that they've been cut into equal parts. That you can't make a comparison if one of these pieces is bigger than another one. So that's really, really important if you're going to use the visual representation to help understand what we're doing or to answer a question. So we could colour these in. I'm going to make a quick prediction first though. The bigger the denominator, you can see, the smaller the pieces are, okay? So that's something for us to bear in mind. However, I know here that 4/5 is nearly one whole, so I'm going to bet this is going to be a biggest one. I'm going to put in my estimation. I still think that's going to be my biggest. Looking at this, I've got 2/9 and 1/6. It's a bit of a toss-up between the two. I think that, I think 1/6 might be the smallest, but only just, and I'd have to do a quick comparison. So let's colour them in. I've got my 4/5 that we're very, very happy with. We did it in the example before. Here I've got 3/8, so it's been cut into 8 pieces, and I'm looking at 3 pieces. Here's my 2/9. Remember, my pieces are a lot smaller as 9ths than they would be as 6ths. And my 1/6. We can see from the visual representation that I was right, of course. 4/5 is the biggest. Next is going to be 3/8. And then it's the toss-up between 2/9 and 1/6. 2/9 is just a tiny little bit bigger than 1/6 in my visual representation. But remember, because my denominator is cut into ninths, the pieces are going to be smaller than into sixths. So I've got here, oh, wrong colour, 2/9 and 1/6. Now, that was using a visual representation to help us work it out. Mr. Slay is going to go into how we could take these, or take some fractions, and we would be able to accurately compare them by using our understanding of simplifying and equivalent fractions.
Right, now, so, yes, as Mrs. Williams has just said, we're going to look at the more technical way of working it out. And to do that, we need to find the common denominator. Now, if you remember, the denominator is our bottom number of our fraction. It's the lower part of our fraction. It's what tells us what things are out of. And the fact when we say a common denominator, that means that both our denominators need to be the same. So in this case, I have 5 3/5, and here 4/6. I have a 6. So I've got to find a common denominator that both the 5 and the 6 will fit into. And I'm going to do this by thinking of multiples. I need a common multiple of 5 and 6. The first one I can think of is 30. So underneath here, I'm going to write my common denominator. So now I need to think of how do I get from 5 to 30, and how do I get from 6 to 30. So let's start with this one up here. So how do I get from 5 to 30? Well, my 5 times table, 5, 10, 15, 20, 25, 30. So that would be 6. So I have to times 5 by 6 to get to 30. And just exactly like using our equivalent fractions, this will be an equivalent fraction to 3/5. I need to do exactly the same thing to the one at the top. So our numerator, so 3 times 6 equals 18. So I now have an equivalent fraction. 3/5 is the same as 18/30. Over here, I'm going to do the same thing, but I've got to do it with the 6 now. So how many, where is my multiple of 6 for 30? 6, 12, 18, 24, 30. 5 times. I need to multiply it by 5. Again, as it's going to be an equivalent fraction, I need to make sure I do exactly the same thing to the numerator. 4 times 5 equals 20. Now, it's very easy to see now which fraction out of 3/5 and 4/6 is larger. And I can see straight away that 20/30 is larger than 18/30. In this case, if I've only got 2, I could use my greater than symbol to show that. If, however, I'm ordering them, and if we go back up here, I'm going to add an extra fraction. I'm going to put 2/10, because sometimes when we're ordering fractions we'll have more than one. I then need to find a common denominator for all three. Luckily, with 2/10, my 30 is a multiple of 10 as well, so I can still use 30 as my common denominator. What do I need to multiply 10 by to get to 30? 10, 20, 30. That's got to move times by 3, which means I have to times 2 by 3. 2 times 3 equals 6. Now I have 3, and if I was going to order them from smallest to largest, my smallest fraction out of the 3 is going to be 6/30. Now I could put 6/30 or 2/10. They're equivalent fractions, it's the same thing. As we started with these numbers up here, I'm going to write those in there. So my smallest is going to be 2/10. Out of these two, we know the next smallest is going to be 18/30, which is equivalent to 3/5. Whoops. And then our largest fraction, 20/30, or equivalent to 4/6. We'll go there. Right, now it's your turn. Here we go. We have 4 fractions for you to order. We have 4/8, 3/5, 1/8, and 4/5. So the first thing you'll need to do is find a common denominator, so a denominator that will all be the same, and then we will need to use our equivalent fraction knowledge to convert them, and then order them on our line underneath. Pause the video now to have a go, and we'll see you in a bit. Right, so hopefully when we looked at our 8, 5, 8, 5 as our different denominators, we know that 8 are the same and 5 are the same, our fifths and our eighths. So actually I just need to kind of find a common a common multiple for 8 and for 5. Thinking about my 5 times table and my 8 times table, 40 comes to mind. I'm going to use 40. I could actually use 80, I could use 160. These are all common multiples of both 5 and 8, but 40 seems to be the smallest amount of jumps. 40 seems to be the way to go. So now I found my common multiple, I've got to think, what do I multiply those by? Here, how do I get from 8 to 40? 8, 16, 24, 32, 40. That means I've multiplied it by 5, which means I have to times 4 by 5, simply because we always have to time the numerator by the same to get an equivalent fraction. 4 times 5 equals 20. And while I'm on the 8s, as this is a denominator of 8 as well, it's going to be the same thing. So I'm going to have to multiply that by 5, which means I have to multiply 1 by 5, which is going to give me 5. And then moving on to my fifths, 3 fifths and 4 fifths. How do I get from 5 to 40? 5, 10, 15, 20, 25, 30, 35, 40. That's 8. 5 times 8 equals 40. 3 times 8 equals 24. Similarly, we know now 5 times 8 will equal 40, so 4 times 8 equals 32. So now I have a very clear way of ordering my fractions. I have 20 40ths, 24 40ths, 5 40ths, and 32 40ths. 5 40ths standing out easily as the smallest fraction, which is equivalent to 1/8, so I'm going to put 1/8 on my board first. Oops. And I'm going to put a little tick, so I've already done that one. I'll tick down here as well. Next smallest is 20 40ths, so that's 4/8. These two, we have 24 40ths, 32 40ths, 24 being our smaller, so 3 fifths. And finally, we have our 32 40ths, which is 4 fifths, as our largest fraction. Ordered and ready to move on. Right, to our number mind map, and we need to add ordering fractions to this. We're going to put it here around our simplifying fractions because we have a lot of linking to do with it. So I'm going to put ordering fractions. And with ordering fractions, we know we need to find a common denominator. I'm going to put that in brackets just so we know. And we know that we need to simplify the fractions sometimes, or we need to find equivalent fractions for these using our common denominator. We can use that by helping with our multiples. So let's bring one from here. And when we're writing them out, we could order them using our ordering symbols, greater than, less than, or equal to, if we need to.